Every day, millions of drivers pull up to traffic lights. They wait for red to turn green, accelerate through yellow, and sometimes try to beat the light before it changes. It's a system we've used for almost a century, organized, predictable, and familiar. But traffic lights also create some of the most dangerous crashes on the road. High-speed turns, red light running, and T-bone collisions happen almost entirely at intersections controlled by signals. And even though we rarely think about it, those few seconds at a light are some of the riskiest moments of any drive. Now, compare that to a roundabout. No red light, no green light, no countdown, just a simple circle that forces everyone to slow down and move in the same direction. It looks confusing, even chaotic, yet it consistently produces fewer severe crashes than almost any other type of intersection. So why does a design that feels less controlled end up being safer? And what is it about a circular road that protects people better than a familiar set of lights? Intersections are where most serious crashes happen. Two or more streams of traffic cross each other, and every driver is relying on timing, judgment, and trust. A small mistake, looking down for a second, misreading a signal, or accelerating at the wrong moment, can lead to a high-speed collision. Traffic lights organize this movement, but they can't prevent human error. Drivers run reds. They speed up when the light turns yellow. They make fast left turns. And when these mistakes happen, the angles involved, especially T-bone crashes, are some of the deadliest on the road. Roundabouts change this entire system. By removing the need to beat a light or guess another driver's timing, they slow everyone down before entering the intersection. Instead of opposing streams crossing at right angles, all vehicles move in a single continuous direction. Studies from countries around the world show the same result. Roundabouts don't eliminate crashes entirely, but they dramatically reduce the chance of severe ones. Lower speeds mean fewer injuries. Fewer conflict points mean fewer surprises. And the circular design removes the most dangerous type of impact, the right-angle collision. So how does such a simple shape fix problems that traffic lights have struggled with for decades? The safety of a roundabout comes down to how it changes the way vehicles move. At a traffic light, cars approach at full speed. They stop suddenly, wait, and then accelerate hard when the light turns green. This stop-start pattern creates opportunities for high-speed mistakes. If someone runs a red light or misjudges a turn, the impact is often severe. Roundabouts work differently. Before entering, every driver must slow down. There's no signal telling them to stop or go. The design itself forces them to reduce speed to a safe level. This alone removes most of the energy involved in a potential crash. Lower speed means less force, and less force means less injury. Another major difference is flow direction. In a roundabout, all vehicles move in one continuous loop, in the same direction. That eliminates the most dangerous type of crash, the right angle or T-bone collision. Roundabouts also reduce the number of conflict points. A traditional four-way intersection has over 30 places where paths can cross or merge. A roundabout has about 8. Fewer conflict points mean fewer chances for something to go wrong. And because drivers naturally look left before entering, they're already focused on what matters most, the cars approaching inside the circle. This simple shift in attention removes the guesswork that traffic lights rely on. Design leads behavior, not by controlling drivers, but by guiding them into safer choices without them even noticing. Roundabouts may feel modern, but the idea has been around for more than 100 years. Early versions appeared in cities like Paris and New York in the early 1900s. Back then, they were called traffic circles, large, wide, and often confusing. They moved traffic, but they weren't designed with safety in mind. Cars entered too fast, lanes were unclear, and many of these early circles created more chaos than order. Because of that, traffic lights quickly became the preferred option. They were simple to understand, easy to install, and gave cities a sense of control. By the 1930s and 1940s, signalized intersections began spreading across the United States, and the roundabout idea slowly faded away. But that changed in the 1960s and 1970s. Engineers in the United Kingdom redesigned the concept from the ground up. They made the entry points narrower, forced vehicles to slow down, and introduced the modern rule that drivers entering must yield to those already inside. This was the birth of the modern roundabout, smaller, safer, and far more predictable than the old traffic circles. Once countries saw the results, roundabouts began spreading across Europe, Australia, and New Zealand. Crashes became less severe, congestion dropped, and drivers adapted quickly. It took longer for the United States to follow, partly because people were used to traffic lights and familiar habits are hard to change. But every place that has adopted modern roundabouts shows the same pattern: less waiting, fewer conflicts, and far fewer serious crashes. Most of the danger at intersections comes from the way traffic lights work. When the light turns green, drivers accelerate quickly. When it turns yellow, some slow down but others speed up to make it through. And when someone misjudges the timing, the result is often a high-speed, right-angle crash. These impacts are some of the deadliest on the road because the sides of a vehicle offer far less protection than the front or rear. At night, or on empty roads, the problem gets worse. Drivers may run lights without thinking, assuming no one else is coming. Even a small mistake at those speeds can turn into a severe collision. Roundabouts change the nature of failure. They don't eliminate crashes completely, no design can, but they make them far less dangerous. Because entry speeds are low, most collisions become slow, glancing impacts instead of high-speed strikes. There's no opportunity for a T-bone crash, and no reason to race against a signal. Everyone moves in a single direction, which removes the most violent types of conflicts. Even when drivers make mistakes entering too fast, failing to yield, or misjudging another car's gap, the outcome is rarely severe. The circular shape forces vehicles to curve naturally, reducing speed even further. Instead of a sudden stop or an unexpected sideways impact, mistakes unfold gradually. Roundabouts don't rely on perfect behavior. They assume people will make errors, and they reduce the consequences when those errors happen. That's what makes them one of the safest intersection designs in the world. The idea that roundabouts are safer isn't just theory. Countries around the world have tested them for decades, and the results are strikingly consistent. In the United Kingdom, roundabouts became common in the 1960s and 1970s. Engineers monitored collision data before and after installation, and the pattern was clear: fewer crashes, and especially fewer serious ones. Drivers slowed naturally, traffic flowed more smoothly, and right-angle collisions almost disappeared. Today, the UK has more than 10,000 roundabouts, and many of its intersections have some of the lowest injury rates in Europe. France followed a similar path. When it replaced thousands of traffic lights with roundabouts, studies showed a sharp drop in fatal crashes at those locations. The numbers were so encouraging that France now has one of the highest roundabout densities in the world. The more they built, the more predictable driver behavior became. Australia and New Zealand saw the same results. Their road agencies found that intersections converted to roundabouts had dramatic reductions in severe injuries, especially for right turn and crossing crashes. Even smaller rural roundabouts showed strong safety improvements, proving the design works in both cities and open roads. The United States was slower to adopt them, but wherever modern roundabouts were built, the outcome matched the global trend. On average, intersections that switched from traffic lights to roundabouts saw major crashes fall sharply, fatal crashes drop by more than half, delays decrease even in busy locations. Different countries, different driving cultures, yet the same safety pattern appears everywhere. The design works not because people drive better, but because the layout leaves less room for dangerous mistakes. Roundabouts don't just make roads safer, they also make them work better. At a traffic light, every driver has to stop and wait, even when there's no cross traffic. Engines idle, fuel is wasted, and long lines build up during busy hours. These repeated stops and starts add up to more emissions and more time lost for everyone on the road. Roundabouts change the rhythm of traffic. Because movement is continuous, most cars roll through at low speed instead of stopping completely. They slow down, check for a gap, and keep going. That simple change reduces fuel consumption, cuts emissions, and makes the experience smoother for drivers. Even in heavy traffic, roundabouts often move vehicles more efficiently than signals. There's no waiting for a green light when no one is coming. There's no need to accelerate hard from a full stop or brake suddenly when the light changes. The flow stays steady, which reduces both congestion and stress on the road. Roundabouts also require less maintenance. There are no bulbs to replace, no electronics to repair, and no sensors that wear out over time. They function in power outages, in storms, and in places where maintaining signal systems is difficult or expensive. These benefits aren't always obvious at first glance, but when cities look at long-term data fuel savings, smoother traffic, and fewer delays, roundabouts consistently outperform traffic lights. They create safety through design and efficiency through simplicity. At first glance, a roundabout and a traffic light seem to solve the same problem: how to manage cars crossing paths. But the way they approach that problem reveals two very different philosophies in road design. Traffic lights rely on rules and timing. They assume drivers will follow instructions correctly, stop on red, go on green, and never take risks. When everyone behaves perfectly, the system works. But when someone makes a mistake, the consequences can be severe. Instead of telling drivers what to do, the design guides behavior naturally. Slower speeds, gentle curves, and a single direction of travel reduce the impact of human error. It's a system built on the idea that mistakes will happen and that the road itself should protect us when they do. This difference reflects a deeper truth about engineering. Safety is not just about control. It's about creating environments where the cost of failure is low. Roundabouts don't eliminate risk, but they shape it into something more manageable, more forgiving, and far less deadly. When cities choose design over discipline, they create roads that work with people, not against them. And in the places that have embraced roundabouts, the results speak for themselves. Roundabouts don't look like much, just a circle of pavement, a few yield signs, and a gentle curve in the road. But that simple shape changes everything about how drivers move. It slows us down without forcing us to stop. It reduces mistakes without relying on perfect timing. And it turns one of the most dangerous places on the road into one of the safest. We often think safety comes from more control, more signals, more rules, more instructions. But roundabouts work because they take the pressure off. They assume people will make errors, and they're designed so those errors don't become disasters. A safer system doesn't always need to be more complicated. Sometimes it just needs to be more understanding of how people actually drive. And that's why a simple circle, used the right way, can save lives every single day.